Let's do example 12. Question 1. Express 4 cos theta minus 3 sin theta in the form of r cos theta plus alpha, where r is positive and alpha is an acute angle. So, is alpha in degree or radian? If it is not stated to you whether it is in degree or radian, therefore just take degree. So just find alpha in degree. So we just need to express this expression in r cos theta plus alpha. So the r form is already given to you. So now you know that you need to use r cos theta plus r alpha. And hence, for this question, you just need to find r form. So you just need to do step 1 until step 5 only. So just copy down this expression equal to r cos theta plus alpha. Since r cos theta plus alpha is already given to us, that's why we let our expression equal to r cos theta plus alpha. But say that this is not given, you just need to look at in front of a. Okay, so this is a cos theta minus b sin theta. So just look at in front of a where we have cos. Since this is cos, that's why this is also cos. So note that this is the general formula of r form for r cos theta minus plus alpha. If we have negative here, minus here, how do you know whether this is minus or plus? The answer lies here, whether it is cos or sine. If this is sine, therefore this is also sine, and hence, if this is minus, therefore for sine, you will always follow the sign here. If this is minus, this is also minus. But if this is plus, therefore this is also plus. So that's for sine. But if you have cos, therefore this is also cos, you need to change the plus minus sign. So here you can see that since this is minus, that's why this is plus. Note that this is actually a compound angle. So just use compound angle formula for cos theta plus alpha. So r stays the same. Using compound angle, cos theta plus alpha is cos theta cos alpha minus sin theta sin alpha. So now you just need to expand r into the bracket. And you'll get r cos theta cos alpha minus r sin theta sin alpha. So this expression is equal to 4 cos theta minus 3 sin theta. So that's for step 1. Step 2 is to compare. So you need to compare this equation. So here we have 4 cos theta. So on the right hand side here, find the terms that has cos theta. So the term that has cos theta is this term. So this means that you need to compare 4 cos theta with r cos theta cos alpha. Note that both terms have the same factor, which is cos theta. So we can cancel out cos theta. And hence, you will be left with 4 equal to r cos alpha. And that is our first equation. And then this is negative. This is also negative. Next, we have 3 sin theta. So look at the right hand side. Which term has sin theta as well? It is this term. Note that both terms have the same factor, which is sin theta. So you can cancel out sin theta. And hence, it is just 3 equal to r sin alpha. And that is our second equation. Step 3 is to find alpha. And to find alpha, you need to do division. So, Is it equation 1 divided by equation 2 or equation 2 divided by equation 1? The answer is the numerator here should have sine, denominator should have cos. So note that equation 2 have sine, so equation 2 should be in the numerator, and the equation 1 has cos. So equation 1 should be the denominator. So we can see that equation 2 must be divided by equation 1. Equation 2 divided by equation 1. So 3 is divided by 4, and it is equal to r sine alpha divided by r cos alpha. Now just simplify this equation. 3 divided by 4 stays the same. For the right hand side here, we can cancel out r. Sine alpha divided by cos alpha will give you tan alpha. Therefore, alpha is tan inverse 3 over 4. So just use your calculator. Shift tan 3 over 4, and the answer is 36.870. So just write your answer in 3 decimal places. And I forgot to mention that for our form, it's just like the concept that we use in LARCA. All the calculations should be done in degree, but the final answer should follow your question. If the question says in degree, final answer is in degree. But if the question says in radian, therefore your final answer should be in radian as well. But make sure your calculation is in degree. So let's continue with step 4, which is to find r. To find r, you need to use equation 1 square plus equation 2 square. This is equation 1, this is equation 2. So let's do for the left hand side first. You take equation 1 and then you square it. So you'll get 4 square plus, and then you take equation 2 and you square it as well. So you'll get 3 square. Here we have equal sign, that's why here is equal sign as well. Next, we will do for the right hand side. Take the first equation and you square it. So you'll get r square cos squared alpha. And then you add it with the second equation and you square it as well. So you'll get r square sine squared alpha. So now we need to simplify this equation. 4 square plus 3 square is 25. For the right hand side here, we can factor out r square. So you'll get r squared times cos squared alpha plus sine squared alpha. And let's recall, this is identity where this is actually equal to 1. So you can just ignore this actually. And hence, 25 is equal to r squared. So next time, if you have r squared cos squared alpha plus r squared sine squared alpha, just write down r squared straightforward. So now we need to find the value of r. If r squared is 25, r is plus minus 5. But since r should be positive, hence r is just positive 5. So just write down r is equal to 5 since r is positive. Step 5 is to rewrite step 1. So let's look at step 1. The step that you need to rewrite is this equation. So let's copy down this equation. Note that we have already found the value of r and alpha. So r is 5 and alpha is 36.870. And don't forget that for this question, we should leave alpha in degree. And alpha is in degree already. So this is our R form for this question.